Hello everyone, my name is Rufia Carrasco and my topic for today is queue, its operations and its types. So queue. A queue is an abstract data structure which is similar to stacks, but in queue it is open at both its ends. One end is always used to insert data, that is enqueue, and the other is used to remove data, that is dequeue. Queue follows first in first out method, where the data item stored first will be accessed first. Take a real life example. In a single lane, one-way road, first car that enters the line first will exit first. Last one will exit last. For more real life examples, we can take the ticket counter line and the bus stops. The following diagram given below tries to explain the queue representation as data structure. A queue can also be implemented using arrays, linked lists, pointers, and structures. So, operations of queues. Queue operations may involve initializing of or defining the queue, utilizing it, and then completely erasing it from the memory. So, the basic operations of queues are enqueue, that adds or stores an item to the queue, dequeue, where it removes or accesses an item from the queue. More functions are like peek, gets an element at the front of the queue without removing it. Is full, checks if the queue is full. Is empty, checks if the queue is empty. In queue, we always dequeue or access data pointed by front pointer, and while enqueuing or storing data in the queue, we can take help of rear pointer. Enqueue operation. There are two queues maintain data pointers, front and rear. So the operations are comparatively difficult to implement than that of stacks. The following steps should be taken to enqueue or insert data into a queue. The step 1, check if the queue is full. Step 2, if the queue is full, produce overflow error and exit. Step 3, if the queue is not full, increment rear pointer to point the next empty space. Step 4, add data element to the queue location where the rear is pointing. Step 5, return success. This following diagram shows enqueue operation. Dequeue operation. Accessing data from the queue is a process of two tasks. Access the data where front is pointing and remove the data after access. The following steps taken to perform dequeue operations are taken to perform dequeue operation. Step 1, check if the queue is empty. Step 2, if the queue is empty, produce underflow error and exit. Step 3, if the queue is not empty, access the data where front is pointing. Step 4, increment front pointer to point to the next available data element. Step 5, return success. This following diagram explains the queue. The functions of queue, that is peek, gets the element at the front of the queue without removing it. This function helps to see the data at the front of the queue. Okay? The algorithm of peek function is as follows. Begin procedure peak, return queue, front, end procedure. Is full, checks if the queue is full. As we use single dimensional array to implement queue, we just check for the rare pointer to reach at max size to determine if the queue is full or not. In case we maintain the queue in a circular linked list, the algorithm will differ. So the algorithm for is full is begin procedure is full. If rare equals to max size, it returns true. Else, returns false. And if end procedure is empty, checks if the queue is empty. Where algorithm of is empty is begin procedure is empty if front is less than minimum or front is greater than rare, it returns true. Else, it returns false. And if end procedure. Types of queue. Queues in data structure are of 4 types. Simple queue, circular queue, priority queue, DQ, that is W. Circular queue is a linear data structure in which operations are performed on the basis of FIFO, that is first in first out principle. The last position is connected back to the first position to make a circle. It is also called as ring buffer. Where operations on circular queue is front and rear, NQ, DQ and time complexity. Front gets the front item from queue. Rear gets the last item from queue. NQ, this function used to insert an element into the circular queue. The new element is always inserted at a rear position. DQ, it is used to delete element from the circular queue. This element is always deleted from the front position. Time complexity is of NQ DQ operation is 0, 1. There is no loop in any of the operations. Application, memory management, traffic system and CPU scheduler. In memory management, the unused memory locations in the case of ordinary queues can be utilized in circular queues. In traffic system, in computer control traffic system, circular queues are used to switch on the traffic lights one by one repeatedly as per the time set. CPU scheduling, operating system after maintaining a queue of processes that are ready to execute or that are waiting for a particular event to occur. Priority queue is a special type of queue in which each element is associated with a priority and is served according to this priority. There are 2 types of priority queue: ascending priority queue and descending priority queue. In ascending priority queue, elements can be inserted arbitrarily, but only smallest element can be removed. For example, if we have elements 4 to 8 in the same order, so while inserting the elements, the insertion will be in the same sequence, but while deleting the elements, it will be in an ascending order, that is 2, 4, 8. Okay, so in descending priority queue, elements can be inserted arbitrarily, but only the largest element can be removed first. For example, if again 4 to 8 are my elements in the same order, while inserting it will be same order, same sequence, but while deleting it will be in a descending order, that is big to small, that is 8, 4, 2. So in priority queue, is an extension of queue with following properties. Properties such as every item has a priority associated with it. An element with high priority is dequeued before an element with low priority. If two elements have the same priority, they are served according to their order in the queue. Applications of priority queue. CPU scheduling, graph algorithms like DJ-Karta, shortest path algorithm, etc. All queue applications where priority is involved. Double D queue or doubly ended queue. It is also a queue data structure in which the insertion and deletion operations are performed at the ends, that is front and rear. Which means we can insert at both front and rear positions and can delete from both front and rear positions. Since DQ supports both stack and queue operations, it can be used as both. The DQ data structure supports clockwise and anti-clockwise rotation in time complexity 0, 1, which can be useful in certain applications. Okay? So the operations of DQ are insert front, insert last, delete front, delete last, where insert front adds an element at the front of DQ. Insert last adds an element at the rear of DQ. Delete front deletes an element from the rear of from the front of DQ. Delete last deletes an element from the rear of DQ. Applications of DQ. Since DQ supports both stack and queue, it can be used as both. Okay? Thank you.